Hi, and welcome back to the Low-Level Devil Channel's OS development using the Linux kernel series. If you haven't seen the previous videos, there's a link to the playlist in the description. In a previous video, we went over how to execute external programs and pass parameters to them. In this video, I'm going to show you how to use the frame buffer to change the screen resolution and draw pixels on the screen. We'll create that as an external program as well, so we can invoke it with the resolution that we want to change it to. So let's get started. Okay, first I'm going to get started by creating a new library. We're going to call it libfb for frame buffer. So I'm going to go over to here and create a new folder. Call it libfb. And since this is going to be a library, I'm just going to copy the makefile from the libmy, and we'll just change libmy to libfb. I think that's all we need for the makefile. It's going in the lib directory. Everything else looks right. So now next we'll want to create a new file. We'll call it FB.C. And we're also going to want a new include file so that other programs can import this. We'll just call it libfb.h. And we want to do some includes here. We need to include two Linux header files, the fb.h and kd.h, because we'll be using structures that are defined in there. We're going to create a couple of defines here just for the purpose of being able to tell what error happened on some of these new functions that we're creating. And let's see, you'll have a, so if there's no frame buffer, we'll return -1, get info error -2, and so forth. And for success, we're going to use 0. So now the first function is going to be FBGetInfo. So this is going to be used to get the frame buffer info. And we're going to take in two structures which are defined in the fb.h. So we have FBvar screen info and FBFix screen info. So one stores the variable info and one stores fixed screen info. So then we're going to have FBPutInfo. And in that one we're going to just pass in the variable info because that's all we can put. And then finally we're going to get the frame buffer as a pointer. So I'm just going to copy these over, put them in the FrameBuffer.c. We'll start with some includes here. We want to include mylib, of course, and libfb. See, fcntl.h we'll probably want as well, and we'll use erno, and probably want, yeah, I think that might be it. Alright, so now I'm going to make these into actual functions, and we'll start with the FBGetInfo. So first we're going to create a file descriptor and use sysopen to open dev fb0. That's the frame buffer 0. I'm going to open it in read-only mode here because we're just getting info. If it fails, we're going to set errno to the fd, and then we're going to return the vid error no fb0. Actually, not vid, this is fb. FB error no FB0. We'll have a little return variable here, which we're going to make a call to sysioctl. So we're going to, and this is actually going to be a new syscall that we'll add. So FBIO get v screen info. So this is used to pass the variable screen info in and request it to be set for us. So if that fails, we're going to set errno to the return value. And and syscalls FD if it fails as well, and then we'll return nope, not vid, FB error get info. So now we have the variable screen info. We also need to get the fixed screen info, and that's done pretty much the same way. So we can just copy this and paste it, change this v screen info to f screen info. Let's see, that'll stay the same. Now we should be able to just close that file descriptor and return. We'll return the FB success value. And yes, this IOCTL is not defined yet, so I'll go through creating that here. Just down in our sys.c in mylib. Let's take a look actually at the syscall table. Remember, this is the link here. So we just want to look up IOCTL, and it's right here. So we can go to this man page for it, and it's simply the file descriptor, request, and then arguments get passed to it. But the arguments are passed as one variable essentially. Okay, so we're just going to define this as sys_IOCTL, and it's going to take in a file descriptor. We'll use unsigned long file descriptor. Then the second part is going to be the command that we want to pass to IOCTL, and then a void pointer arguments. And simply we just, like the others, syscall, sysIOCTL, then pass in these fields here, FD, command, and arg, and then 0 for everything else. Now we'll take that and put that in the header file. So down here, extern, and there we go. Alright, so now back to our file buffer code. So this vScreenInfo takes the VI, that's the argument that we are passing into it. So now with the FBPutInfo, we're essentially going to do the same thing. So we're going to open up the, open up the FB0, and we're only going to do, actually let me just copy and paste all this because we're going to do essentially the same thing, but this will be, instead of FBIOGet, it's going to be FBIOPut and vScreen, and VI, oh, looks like we might have used the wrong variable there. This will go put. Now we'll go on to the FBGetBuffer. So for this one, we need to actually grab the fixed screen info. So we can do the same thing we did here again. Just open this and read only. And let's see. Gonna do the same as up here. Gonna make our return variable, and fScreenInfo, that should be FI. It should be FI up there too. So we change that. And FI, and pass in the address of FI. Okay. So now, once we have the buffer, once we get the screen info, we want to create a buffer, a void pointer, which is called FB, and we're going to use sysmmap. And this syscall we did in another video we discussed that, and we're just going to take the length of the screen buffer, part read, part write, and map shared. Let's see, the file descriptor and the offset is 0. So now that we have that, we can just close this FB0 file descriptor and return the file buffer. So now let's see if we can actually build this. Let's go to libfb, run make. There's a couple of warnings. These are just warnings, but I might want to go ahead and just cast them to void. Just want to cast these constants to void. See there. And here. So now if we make that, and it's complaining, okay, yeah, it's looking for S files as well, but we don't have any S files. We need to take that out of the make file. Now we should be able to make, there we go, and sudo make install, and you can see it's going to the myOS lib directory. So there's our frame buffer library. Now in order to use it, we'll create a new program which we'll call FBSet, which will allow us to set the resolution and put some pixels on the screen. So in order to do that, I'm going to create another new folder. We'll call FBSet. And it's going to be a program similar to how lash is, so I'm going to take lash's makefile. Paste it in there and just change lash to FBSet. And also it's going to import libfb, so -lfb in the load flags, the linker flags. Alright, now I can close these out. And I want to have a C file here, FBSet.c. We're going to start by including the mylib.h and let's see, our libfb.h. We'll do errno.h and printf as well, and fcntl too. Alright, now so we can start with the main function, argcount and argv. So we'll start by just printing out saying the frame buffer setting. Now we'll just make sure the number of arguments is correct. If it's less than 3, we're going to print a simple usage statement saying you should pass in the xres and the yres. And then we'll return -1. Okay, now so first we're going to grab the console. We're going to use sysopen to open dev console as read write. Now we're going to create instances of these FBvar screen info and FBfix screen info so that we can make the call to FBGetInfo and pass them in. And remember, we're going to have to pass the address of them because it expects pointers. Okay, I'm not going to do too much error checking here since I'm just showing you this for, learning purposes and not creating a solid operating system. So now I'm going to grab the xres and yres from these two arguments, argv1 and argv2. Now we can print out some information here. We'll say, the current resolution is %d by %d. And we can get those values from vi.xres and vi.yrez. So And now we can just printf saying that we're setting the resolution to %d by %d. And we'll use our own xres and yres values. And now what we want to do is actually invoke the FBSet function. We'll just do a simple error check here. If FBSet equals FB error get info or put info, then we're going to print out saying that it failed to set the buffer, and we'll print out the error no as well. So %d error no. And return -1. Alright, and next we're going to, you know what, I'm going to change this. We'll just say if it's not equal to FB success. That way if there's any other error, that it also returns there. Alright, so now we're going to grab the frame buffer with our FBGetFrameBuffer function. So that gives us the frame buffer and one giant pointer, essentially. So now we're going to again call FBGetInfo. This isn't really necessary. I'm just kind of making sure that that works after calling FBSet. It's kind of some debugging info. That happens, we're going to want to return an error as well. Alright, so next, now that we have the frame buffer, we're going to sleep 2 seconds before we do any of these other changes. So we've set the resolution, got the frame buffer, and now we're going to essentially loop through each pixel of the frame buffer. We'll go through the X and the Y based on the XRes and the YRes. So now in order to calculate the location of an individual pixel, we need to use X plus vi.xOffset times vi bits per pixel divided by 8 plus y plus vi.yOffset times, and then there's a variable, it's on fi dot line length. Yeah, there it is. So this is how we get the location of a specific pixel at an x and y coordinate. So now that we have the location of that pixel in, this would be the location of it in our frame buffer. So now we can say, we'll create another variable here, a uint32 pointer pb equals uint32 pointer cast. We'll say pbuffer plus location. Now we're just going to dereference that and set it to all F's, which is white. So we're going to set the color to white for that specific pixel. And now we can take this and actually turn this into a function. So let's go up here and we'll create a simple function, fill frame buffer, fill FB. XRes and YRes, paste this in. Actually, I think we're going to need to use these full variables. So instead of XRes and YRes, we'll take the var screen info. So we change those to pointers. Yep. Yeah, and FI, so we're going to need a FI as well. And pbuffer, we'll need that too. Okay, there's more on this function than I thought we'd need. So we have the buffer, the variable info, the the fixed screen info. Okay, and we're going to be setting it to specific colors, so we want to pass in that color too. So color, and I'll just change this to here. So now we can just call this fill FB, makes that a little more readable. So we're going to fill it to the PBuffer and VI and FI to this white value. So now that we've filled the screen buffer with all white characters, we can now fill it with other characters too. So I'm gonna, sorry, not characters, pixels. So I'm going to make a red one as well. So with red, it's going to be the first two are FF and then 0000. The first byte is the alpha channel, so you can pretty much ignore that one. But then we have R, G, and B. So if I just change each of these, I'm going to essentially sleep 2 seconds, show red, sleep, show blue, show green. Alright. So now we have the RGB values. Now one more thing that we're going to want to do, we want to make a syscalls call to the FD console, and we want to actually set the mode to graphics. This prevents us from having the cursor displaying when we're trying to set colors. Actually, what I'll do is I'll do it after I set the white color, so you can see what it looks like if you don't do this. So I'm going to set white, then I'm going to set to graphics mode, then I'll set RGB. You'll be able to see the difference. So then after we're done, we need to set this back to KD underscore text. Alright, now we can just return. So let's go ahead and make this. So if we go to FBSet make, no syscalls, looks like we need to rebuild mylib. Also no location, that's required by the C standard, so we need to, actually not the C standard, but that's the glibc implementation, which we have the headers for. So I need to add that to our sys.c as well, or util. So down here at the bottom, I created an no value equals 0, and then a pointer function called underscore no underscore location, which just returns the address of the no value. The details of that aren't really that important, it's just used by the no header. So now I can make and make install, go back to FBSet and make that, and make install. Okay, so the next thing we would want to do is I want to update lash. If you remember in here, we implemented the ability to look up a function, look up an external program by its name. But I need to make a little bit of an extension on this. So if the PID is not 0, we want to wait for it. In order to do that, we need to use a couple of structures here, get the status of it, and we're going to need to call syswaitID and pass in the PID, the process ID itself, a pointer to that siginfo structure, and wExited. So now, what is that syswaitPID? Let's go back to this, so this syscall map here, and wait ID. We can go to the man page for that as well. And you see it takes several different options here, the ID type, ID, siginfo. We're just going to copy this and put it into our header as well. First I'll just paste it down here in our util.c or sys.c. Okay, I'll just do some pasting here, clean this up, just fast forward it a little bit while going through this. Put that in there. Alright, so now I'll make that extern. Alright, so now in the function implementation, we're just going to call syscall sys underscore wait ID. Pass in each of these values, the ID type, the ID, info P, options, and then 0 for everything else. So this is going to wait on an ID that you pass into it. And let's see, it looks like there was an error. Scroll up here, ID type. Yeah, I think it just doesn't like that, so I'm going to need to cast it. That's fine, we'll cast it to, let's see, incompatible types. Let's see, okay. Yep. Alright, so I'll just cast that to an unsigned long or something. So unsigned long. If I can spell unsigned. There we go. Alright, so we can make again. Okay, and that works. Sudo make install. So let's go back to FBSet. I can do make, let me see, is that the right one? Oh, we were in lash. So I can go back to lash. Let's see, PPID. We're passing in the process ID, and the exited is the option we're looking for. So let's go back to lash, and let's also print out the return status too. So we can say print process returned %d, put in that return value. And now sudo make install. Alright. So now we can go back, see, to FB.c. Couple in input info, there's a error here. This should be RDWR, and this one down here in FBGetBuffer should also be RDWR. The only one that needs to be read-only is the getInfo one. So we make install that, and then there was another issue in FBSet. So if you see here, we get the X and Y resolutions, we print them out, but we aren't actually set them before calling the put. So let's update these values. So we do vi.xres equals xres, vi.yrez equals yrez. Actually, there's a virtual value too. So there's a virtual xres and a virtual yrez, so we want to set both of those. So what I'll do is vi.virtual xres virtual equals xres, and vi.yrez virtual equals yrez. So now that we updated that, we should be able to get these values and go back and rebuild that. Okay. KD graphics error. Yeah, we can just cast that to a void pointer, and here too, just so we have a clean build. So there we go. Make. Now we make install. Alright, so let's go ahead and reboot. Sudo reboot. Okay, so I choose my OS, put it up, and we get our initializing, and now we have our prompt. So if we want to call, move this a little bit, if we want to call FBSet, let's say 640 by 480, Now you can see that it actually changed our resolution and set to white. You see the blinking cursor, and now red, there's no blinking cursor, green, and blue. That was due to the to setting the KD graphics value. So now let's try a couple different resolutions. 800 by 600. See, it changed it. And again, we have the white with the text cursor still on it. And now the graphics that removed that cursor. Red, green, and blue. And we'll do 1024 by 768. Okay, that made the screen that much larger. And fill in all the pixels. So now that we're able to do this, let's do one more simple update here. So I'm going to reboot. Now I'll just put it back to the init program. So before we had this message, it would print out. So now instead of printing out this message, let's actually display a graphic for our OS. And so in order to do that, first I'm going to include the libfb.h, and let's see, linux vt.h we need. Okay, first I'm going to create a function to fix the colors in the image that I created. So fix color, we're going to pass in the color itself. I'm just calling it num. So we're going to return num masked by ff00, ff00, because these two 00, those values, we actually need to swap them. So it's actually returning green, blue, red instead of red, blue, green. So I just need to first take, let's see, the green value, shift it over by 16, then take the red value, shift it the other way by 16, and AND it with, so that we just get the 1 byte. And if you don't understand that, you know, leave a comment and I can explain it further how that bit manipulation works. Let's go ahead and remove this. So first we want to open the FB console because we want to make this in graphics mode. So we use RDWR. sysctl, and let's see, it's KD set mode and KD graphics. So we set it into graphics mode. Now we're going to create these two structures, the variable and fixed screen info. We'll get the screen info. And let's see, this time we're going to actually force the screen resolution to 1024 by 768. So we'll do this kind of the same as we did in our FBSet program, but we're hard coding the values here for fun. And normally you do a lot of other error checking here as well, but you know, I'll just add a comment, add error handling here normally. For this, you know, this is just a demo purposes, so I'm going to call FBPutInfo, pass in that variable info. Now I'm going to grab the frame buffer, same as we did in our FBSet program. So let's see, now I'm going to open this file. This is a raw image file that I created. It's in /etc myos.image. And I only need to read it, so I might as well just use read only. Actually, if I go in the terminal here, I'll show you. I put it mount myos etc. There it is, myos.img. And I'll put this in the repository as well so you can use it. So buff size equals size of int times 1024 times 768. So now we're going to create a buffer, and use our malloc program that we created, our malloc function that we created a couple videos ago. So we're going to allocate a new buffer to contain all the bytes in that image essentially. So we're going to call sysread on the file descriptor, pass in the buffer and the buffer size, and then we can just close that file. So this is all reading this image here into that buffer. So in each int is going to be a pixel on the screen essentially. So I'm going to start at pixel 0. I'm going to use I for the index of the pixel. So now I'm going to loop through each line. So the Y is the line on the screen. I'm going to loop through each horizontal line on the screen. So same as we did in our FBSet fill color function, I'm going to use this same logic to find the location of this X and Y pixel. So Y plus vi.y offset times fi.line-length. And again, we get this, create this int32 pointer. That is the frame buffer plus the location. Dereference it and set its color. Now this time, the color we're going to set it to is, we're going to be using that fixed color function first of all. We're going to pass in the buffer at index I. So that's our buffer that contains the image. And then I is the current index we're on, and we're going to increment I each time. Okay, and we'll change this sleep seconds to 5. Okay, and go into init, call make, and FBGet. Okay, I need to include this in the make file. So init also now needs the libfb. So now if I make, you can see it works. So I can sudo make install. And actually one more thing I gotta fix. Remember we set the graphics up here, graphics mode. We need to actually set it back to text mode before calling lash, otherwise you're not even going to see any of the text on the screen. Alright, so if I do that, let's go back into init and make, sudo make install. Now we can reboot and see what it looks like. And make sure to choose My OS. So now it's booting up, and now there you go. There's the My OS splash screen, I guess you could call it. And now it goes into the prompt. So one more thing I want to show, if we call FBSet and try to use a large one like 1600 by 1200, notice we get an error here, and it says the geometry can't fit in the frame buffer, and that's because my frame buffer is too small to fit. There are many issues with using the frame buffer. It's sort of the older way and easier way to change the resolution and draw pixels on the screen. Also, there's no way to use hardware acceleration with the frame buffer. Older Linux OSs, they were fine with this because they would run X Windows as the root user, so it would have access to hardware directly. But in modern systems, modern Linux systems, they make use of something called KMS and DRM. And this is the new preferred way for doing graphics in Linux. And I think that'll probably be the topic for the next video. It's a little more complicated to use these kernel APIs than it is to use the frame buffer. So I wanted to start with this as a simpler way if you choose to do it instead. I hope you enjoyed this video and learned something from it. If so, like and subscribe and comment with any questions you may have. And thanks for watching.